Welcome back, Captain Ron here. Haven't made a video in a couple months, been pretty busy with the flight training and all, but today what I'd like to do is explain to you and make sure you get a good understanding of how to pass your oral testing part for gyrocopters. Now, I haven't found an online course yet that teaches you about gyrocopters. So most of your testing and online courses have to do with airplanes. Now, most of the practical test standards, they include such as flight cross-country planning, airspace, aeromedical factors. All of these items in the practical test standards, pretty much 80%, you can actually learn this from an airplane CFI. But there are two tasks in the practical test standards that strictly have to do with gyrocopters, and you have to understand this before you can pass the oral. One is principles of flight, and the other one is performance limitations. And I kind of roll these two together, but if you watch this video, then you will have a basic understanding of how all this works and what I, as a flight examiner, expect. And I'm going to keep it real basic. Gyroplanes are basic. Now, we'll start in as how the rotor blades work. Now, the rotor blades will spin freely only once you pre-rotate and get them started and get some airspeed under them going down the runway, and they'll speed up to the proper RPM. Now, the design of most two-bladed teetering rotor systems all work the same. Now, you have a lot of different makes and model gyrocopters out there. And from here down, they're all different. They have fancy fuselages and instruments and what single seats, two seats, tandem, side by side. Everything is different. However, they all have rotor blades. They all fly the same. You fly the rotor blade, you don't fly the fuselage, because obviously you're not connected rigidly to the rotor system. So, okay, how do the rotor blades work? All right, they spin in a counterclockwise position, a rotation. Now, if you can imagine, this blade is going forward in the relationship of your aircraft is going forward, let's say 50 miles an hour. And let's say the blade tips are going 300 miles an hour. So this rotor blade goes 350 miles an hour. This guy, he's going backwards. So you got to subtract that. So they fly at different speeds every time they rotate. Okay? Now, there's a lot of big words that they use to explain the geometry and the design of rotor blades, like advancing, retreating. You don't really have to know all this. You just have to have a basic idea of how the rotor blades work. And the most important thing you have to know about rotor blades is how not to flap them. And I'll explain the flapping regions and how to avoid flapping. But the rotor blades will teeter. And teetering is a little bit of this. Every time they rotate, it teeters a little bit. And that just compensates for more lift on the advancing and less lift on the retreating. That's all that does, and that's all you need to know about them. Now, when they teeter excessively, then they hit the stops and they flap the cyclic forward and back like this. This is excessive. This is blade flap. Now, if you allow this blade flap to continue, then the blades obviously aren't turning fast enough to become rigid with centrifugal force. So they're real flexible when they flap around, and they'll come down and hit the tail, the prop, and then eventually the aircraft rolls over. And I've made some other videos that give you a little more detail on it, but I just want to explain to you the basic flapping regions, okay? Now, when you pre-rotate the gyrocopter and the rotor blades, the blades are forward, they're flat, they pre-rotate, you move the cyclic back, full angle of attack, and you add power to get down the runway. Okay, as long as you have, and most manufacturers will give you a green zone in the rotor RPM. So if you follow the manufacturer's recommendations and pay attention to what you're doing on the very first takeoff, that's the most critical. You want to get the blades going and the stick is back and you're going down the runway. Now, at this point, this is the first region of blade flap. You've successfully gotten through the first region, okay? Now, at some point in time, the nose is going to come up. You're going to have to go forward on the cyclic, and what that does is flatten that disc out, reduces the drag, and lets this propeller push you through the air faster. You need airspeed. You need rotor speed, airspeed to get off the ground. Now, if you can learn to do soft field takeoffs efficiently, then you keep that nose off the ground. If you pin it down too much and you move the cyclic back and forth, you don't get any reaction. No telltale signs what you're doing. If you keep it light and you keep it bouncing a little bit, you're going to gain airspeed. You're not going to starve the rotors for RPM and airspeed, and then you're going to take off successfully. In lots of cases, people with the new European gyroplanes, they can pre-rotate real fast, 250, 300 RPM. That's close to flying. Okay, at that point, most people pre-rotate, cyclic back, full throttle. And now they push the stick forward, they're going down the they're going down the runway too fast, they flatten the disc out too much, the rotor blades aren't spinning up, and then they realize, uh-oh, pull the stick back, and they flap and roll over. So, two regions. The initial run-up, pre-rotation, down the road a little bit, make sure you bounce that nose wheel off the ground, keep it light. Yeah, another subject I want to touch on is if the aircraft is aft CG, excessive aft CG, the consequences of that. Okay? The consequences of aft CG is the tail is going to be down further. And if you move the gyroplane tail down or nose down, you're actually using the cyclic movement. So obviously if your tail, excessive tail heavy, you're using some of your forward cyclic. So the end result is you can't get enough speed. The nose is going to be high all the time, and that could be a problem. Now on the other side of it, when you're too nose heavy, you're using up your aft stick. The nose is heavy because it's excessive CG forward, and you're going to have trouble flaring on the landing. So, keep in mind that an airplane, the fuselage, the wings, everything is connected as one unit. And a gyroplane, you're a pendulum. So that's why you fly the rotors, and the rotors pull the fuselage in the direction that you fly the rotors in. Okay. Now, let's change subject, and we're going to go to the backside, the power curve. That's another cause of a lot of accidents. The backside of the power curve. That means that these rotor blades can create enough drag to outpower the engine. In other words, if you get the nose too high on takeoff or landing, you're gonna let's say on takeoff, if you get off the ground and you don't have enough airspeed, you have rotor speed, no airspeed, and you just barely get off the ground, you're on the backside of the power curve. Now, if you don't make any control movements with a cyclic, you're going to get out of that ground area and you're going to sink right back down again. So, if you're proficient in soft field takeoffs, then you learn how to bring the nose up a little higher, get off the ground, lower the nose, pick up your speed, climb out. So that's when the backside, the power curve, helps you. The same way with landing. You're coming in, you do your initial flare, you hold it, you add a lot of power to slow that descent down. You want to slow that descent because you're getting slow, nose is higher, slowly touch down. That's the soft field landing. Okay, so we covered rotor blades, we covered backside the power curve. Now the next thing we want to cover is power pushover and porpoising. with these European gyroplanes, they're very stable. They got a good tail section on them. You don't get into the porpoising. Porpoising is when you're flying and you over control the cycling forward and back too much, and you start going up and down, and eventually you can push it over, and then once you do that, it's usually a fatal accident. So keep in mind, the faster you go, some of these gyroplanes now can do 120 miles an hour. In order to get more speed, you got to flatten that rotor disc out. Flatten it out, flatten it out. Think of this as a disc. And the more you tilt the disc flat, the less drag, the more this propeller engine can push it faster forward. Okay? Now there's a point there when instead of the incoming air hitting underneath there, it's kind of right on the verge of power pushover, because you can only get this rotor disc so flat to get all this high speed out. And then if you hit a gust or whatever, turbulence, you can actually do a negative G maneuver and flip it over. So I suggest you don't go 100 miles an hour in a gyroplane. If you want to go fast flying, then I suggest you get an airplane, because gyroplanes are recreational. They're out to have a lot of fun. They're a safe aircraft, but you have to fly and stay within the parameters, the limitations of the aircraft, and more important, stay within your limitations. So I hope this helps, and thanks for watching.